Good day, students. As you can see, what we have today is circle geometry. Four congruent squares are inscribed in a semicircle as shown. Find HQ and the area of the four squares. You are required to find the value of HQ and what the area of the four squares. Since the squares are congruent, which means they have the same properties. Since they are congruent, they have the same property. All I need to do is to see if I can join. Let's join it. Join here. So you also join here. Alright, so the first thing after our joining, we are told that the CH, we didn't write it CH in this case. CO was given to be 4 root 5 cm. So this was given as well, 4 root 5 cm. So you are required to do what? To find what? The length HQ and what? The area of the four squares. Alright, so let's proceed. Since CH is given, CO is given, we have to know that CO is equals to what? Is equals to HO. The reason is radius of the semicircle. Radius of the semicircle. So once we know that CO is equals to what? HO, which is what? The radius of the semicircle, and is given. So we can say we can assign a value here. We can say let this place be equals to V. That is the middle of the triangle QOH. Let it be equals to V. So in this case, we have a triangle in this form. So here is H, here is V, and here is O. So we can say let H, since we know that this is a squares, they are all squared. So I can say I can call this place T, so that what? HT is equals to what? X. Let it be equals to X. So once I say that is equals to X, which means that HT is equals to what? VO. Is equals to VO. Reason side of a triangle are equal. Side of a side of a square. Side length, let it be very simple, or the length of a square are equal. Length of a square are equal. Length of a square are equal. Alright, since we know that the length of a square are equal, the next thing is we have already assigned HT to be equals to what? To be equals to X, which is equals to VO. So which means VH is double the length. Here will be X, here will be X. So this will be 2X, and here will be what? Here will be X. We know that what? CO is equals to what? HO, radius of the semicircle. Here is the radius, here is also radius. So therefore HO we know to be equals to 4 root 5. So the next thing is to use Pythagoras theorem to find the value of X. Pythagoras theorem to find what? X. So if you use Pythagoras theorem to find X, we have what? We have 4 root 5 squared is equals to 2s squared plus s squared, and this 2 term here is equals to 5s squared. So find the square root of both sides. Find the square root of both sides. You have 4 root 5 is equals to x what root 5. Divide both side by root 5 so you can get the value of x. Divide both side by root 5. This means that 4 is equals to x. So having gotten 4 to be equals to x, which means VO is 4, which is what? We are asked to find what? HQ. So if here is x is s, here is x, here is x. So we have a many x? 4x. And we got that x is equals to what? 4. So from here we arrive at s equals to what? 4. So 4s will be equals to what? That from the HQ you are looking at, you are asked to find. HQ is equal to what? 4x. This gives us 4 times 4, since x is equals to 4, and we have what? 16 cm. So you are asked to do what? Find the area of the 4 what? 4 squared. Area of one of the squares, since here is s, here must be also x. This is not drawn to scale. That's why it looks like triangle, not drawn to scale. So these are squared. The sides are what? Equal, but not drawn to scale. That's why it looks like what? It looks like triangle. So HQ is equals to 14. The area of the square will be what? Area of the 4 square. Area of the 4 squared is equals to 4 times area of the one of the square, which is equals to 4s squared. Because we are looking for the 4 square, area of the squares 1, 2, 3, 4. For 1, it will be 4 times area of one of it. So in this case, we have what? 4 times s is equals to 4 squared. So it's equals to 4 times 16, and we have what? 64 cm squared. So the area of the 4 squared is equals to 64 cm squared, and the value of what? HQ is equals to 16 cm. So this is how you can solve this problem involving what? Involving inscription of 4 congruent circles, or 4 congruent squares in a semicircle. If you enjoyed this video, please click the subscribe button so that whenever we have new update, we will send you a text. Then please like and share. Click the subscribe button to encourage me, to encourage us to bring more videos for your view. If you enjoyed this video, click the subscribe button. See you in the next lesson. Bye for now.